Geometry A, review for benchmark. Quick proofs, so you circle the congruent thing up here. The first line we made A plus B equals 180, that's supplementary. The second part, we did B plus C equals 180, that's also supplementary. On this line here, we're going to subtract the B from both sides so that you can see that that will give you A equals C, which is what we wanted to show, that A, rather that A and C equal 180, or rather they're congruent because they're vertical. And then the final answer, the three triangles, or the three dots which form my little triangle, represents the word therefore. All right. Do I have a highlighter? Who will let me highlight? Will you let me highlight? No, you're not part of this thing. Oh, this thing up here? You let me highlight? It's kind of big. But to remember it, highlight the line. In other words, you can draw a straight line. You know that the two guys on this line equal 180. The B plus the A plus B equals 180. Highlight the other line. The B plus the C equal 180. Then let those two things equal each other, because you're not going to have all this. You're going to have it memorized. The guy that matches up on both sides, get rid of him by subtracting him, leaving you just the two other guys, which happen to be the two guys that you want to win. They may use different letters, but line, line, equal, minus, the end. All right, let's pause that. The therefore, you just have to restate what they want you to say at the beginning, and you'll notice it's the same thing. That is it. As you can reproduce what you see here, you get that point. No. Number 2. Prove the triangle sum theorem. That one we would have you underline. Triangle sum theorem, which simply says the three corners of a triangle always add up to 180. So here's our plan. Well, I'll just go through it. Step 1, say something that you do know. One thing that we do know is that A plus B plus C equals 180 because they're on a line. That makes them supplementary. So we write out something we know. A plus B. Dang it, I got to write the whole thing. Measure of angle A plus measure of angle B plus measure of angle C equal 180. I'm going to put supplementary. Okay, what else do I need to know? If I could say that A equals D and C equals E, then I'm going to be able to say something about about the inside numbers, the B, the D, and the E. So let me do that right now. How do I do that? I do that with a highlighter. The big highlighter? I'll do it with this guy. A red Z, alternate interior angles. If you're trapped inside of a Z, you are equal to each other. So measure of angle A is equal to the measure of angle B. How do I know they're alternate interior angles? It's too much information. Hopefully me saying it. You watching the video. Do it again. Thank you. D as in dog, not B as in boy. All right, D as in dog. Let's do it in blue. Here comes the other guys. If C equals E, put a Z. As long as they're inside the corners of a triangle, rather of the letter Z, measure of angle C is equal to the measure of angle E. Same reason, they're alternate. They're on opposite sides of the Z. Interior, they're inside the top and the bottom of the Z, inside the parallel lines, angles. What do I say last? What do I say last? What do I say last? Down here. I'm going to do it. I'm going to see how it's going to work. So I'm going to mess them up. If you're watching the video, this top box, I'm going to change the A into a D. This third box, I'm going to turn the C into an E. Let's see if I can do that without messing everything up. And then because of substitution, I can say that they're all equal to 180. So what is he about to do? He's about to say, instead of a measure of angle A, he's going to do a measure of angle, you are a D. We do you in red, because you're part of the red family. And this part over here, the measure of angle, let's make you blue, E. This dude here in the middle, he's just going to say himself. Again, if you have to lose one on the test, you can lose this one. The reason I'm doing this one is just there's some people like, look, I want as many points as I can get. So just give it to me all. The other part equals 180. And for this one, you just put substitution. Substitution. And what that means is you substitute it in a D for an A. and an E for a C, well, if these three guys equal 180, and these three guys are the same amount as these guys, well, they must equal 180 as well. And that, my friends, is the answer to this very long problem. Let's pause it. These handrails have lots of parallel lines. Point out and label corresponding angles. Go ahead and circle corresponding angles. Point out and label alternate interior angles. That's it. That can't be on the test. It must be the bottom section. I'll mark it on here, but this can't be the thing. Point out and label. If you know how to do that, mark it on there. Do one color for corresponding, one color for alternate interior. Here's your hint. This line here in the middle is your transversal. Corresponding angles must be on one side of the transversal. Alternate interior angles must be on opposite sides. So if you're trying to draw something, go ahead and do that. So let me pause for just 30 seconds. I would draw the red lines there. Normally, our picture, we have this thing, and then we have that thing. On a normal situation, corresponding, the blues, they're on the same side of the line doing the same thing. You and you are corresponding. You're doing the same thing. We're both sitting on top of a red line. If I did it on this side, which I shouldn't do, you and you are corresponding. You're both hanging on to a red line. Corresponding, same side, you're doing the same thing. So again, 1, 2. There are other answers out there. Mark the blues. How would they do it? If I were doing it, I would go click, click, and I'd put corresponding. Just double core. Angles. Angle sign with an S means more than one. How do I do the green? The green has to be in between the two red lines, but on opposite sides of it. Here it comes. You and you. You guys are alt, int, angles. So we're trying to get all the information you all need, but some of you are going to study for next time to really take care of it there. As I'm almost positive, based on the other numbers that we need to do, you won't have the maximum amount of time, but next class, Wednesday, if you study, you watch your video at home, this video here, it should be it. Whatever. This line here in red, I'm not sure. Oh, I was going to do that. That black line is called a T for transversal. It makes a double T. This line here is T transversal. That's what that line is. The one that slices the red guys, he's called transversal. Dang it. I'm not sure if I just turned off the recording, but the bubbles are going towards the answer for number 2. Mark what you see on your paper. What we wrote for number 2, the corresponding angles is underlined in red, which means it would work for alternate interior angles, underlined in red. Corresponding angles, underlined in red, or even alternate exterior angles, underlined in red. Right now we're looking at the benchmark itself, so this handout that you're on looking at right now is from the benchmark. 3 comma negative 1. Again, since I'm doing a factor of 2, I'm just going to multiply by 2. And I'm only doing one of these. I'm not going to do the other 3, but just so no one has to miss this one. So now the new coordinates for the factored version, or the dilated version, is going to be 6, 2 times 3. 2 times 3 is 6. 2 times 1 is a negative 2. And then you do that. Some people thought the triangle would go around it, but it doesn't. It actually, since it's the point of dilation, when you build the balloon, and the balloon gets bigger, it starts here and it starts shooting down. So it starts shooting down small, now shooting down big. 6, negative 2, where are you? 6, negative 2. 6, negative 2, here you are, and you are, make sure when you rename it, put down the primes. You get 3 brand new points. You connect the lines, and voila. Voila is a French word. V-O-I, just in case you ever hear it. Voila, because the V in French is more like a W-ish. The R is more like a W as well. We found out when we went to France. We were looking for the We're looking for the Rosie bus. So we asked the French lady at the desk at our hotel, hey, where'd you get the Rosie bus? I said, Rosie bus? The Rosie bus? Do you know the Ross? Oh, Rosie bus. You know Rosie bus, you just go down there. Oh, okay. That's when we find out the R is a W. No Rossi, only Croise. Croise boost. Alright, tick, play. Hey, parameter. Put under that add around, just in case you forgot, add around. Number that add all outside numbers. Add all outside numbers. Add all outside.
He doesn't know who it is.
Some people may not be you. All right, outside numbers. All right. Some people hate math. You know that? They hate it. They'd forget it right now if they could, but they have to remember to take a test. After they take the test, boom, gone. All outside numbers.
What's funny is what's going to be an accountant.
Boom, you can still do it.
Handshake.
Area. Well, by the time you become an adult, you'll do it for money, not for love. All right, area. You're going to multiply outside. Multiply two outside numbers. Multiply two outside. The reason I'm doing the outside thing is some people are going to want to do some of that 15 because they're figuring math. Well, if they gave me the 15 to get my final answer, I got to do something with at the very end. But no, once you get what you need, it's all about the outside numbers. 15 will help you get what you need. 15 is like a friend helping you hook you up with somebody. After they hook you up, like, all right, we're cool. See you later, man. Yeah, like that. 15 is like the person driving the car. They drop you off at that place you're not supposed to be because you can't drive. But then it's cool. You can go home now. Pick us up later. All right, so here's the deal. Oh, what can I say to them? A squared plus B squared equals C squared. I'm going to give you the official thing, but I'm going to tell you, those of us who know how to do it, what we see. And you decide, if you see the same thing, use it. If you need to do the official guy, plug it in. Do the official guy. It goes like this. To get the answers to these problems, either you're going to add or subtract. Add or subtract. The question is, how do you know when you add? How do you know when you subtract? It's the big middle number. If you had a highlighter, you would highlight the red line. The rule simply says this. If the number on the red line is missing, you add. If the number on the red line is there, you subtract. I got it right there in a neat way. The red line is the hypotenuse.
Hypotenuse?
That's all right. The one time you can use it. All right. Hypotenuse. Hypotenuse there. Subtract hypotenuse missing. Yes, hypotenuse. Yes, I have it.
You have it on you? Damn, see, go ahead.
There. Hypotenuse there. Subtract. You know they canceled the show. Well, they didn't cancel. The guys decided to stop making it. Yeah, so one guy can make movies, and the other guy, he has another TV show on. If it's there, if it's missing, you got to add. So let me ask this question. Just knowing that, and it's just going to be memory, so some people will stick with it. When you look at this problem, I need to find out what this side is equal to. The hypotenuse is there. So am I going to add or subtract?
Yeah. You subtract the 2, the 9, and the 15.
You got to subtract. You got to subtract because the hypotenuse is there. They gave it to you. If the 15 were missing and they gave you the two side numbers, let me see if I can do it this way. Brand new guys. Now again, you can do it the official way. The hypotenuse is always C. Now 9 is A or B. The one that's missing, plug it in, work it out. You'll get the answer. But for those of us who know how to do it, we know all we have to do is check the hypotenuse. Yeah, I don't know what that one was going to be. I'll do a famous one. The 5, the hypotenuse is there. The hypotenuse is missing. Let's make you a 4. These are famous ones. You'll see these over and over. These number 3, 4, 5. You'll see their friends, their doubles. 6, 8, 10. Those two famous Pythagorean triplets, they call them. But here's the deal. The question is, hey, on this first one, Thomas, give the answer. You're going to add or subtract. I know I'm going to subtract. How do you know? If this number is here, the hypotenuse, to get the guy that's missing, I'm going to do 5 minus 4. Now there's more to it, but that's how it begins. On this one down here, the guy's connected to the box. If I have both of them, that is the hypotenuse is missing. I need the longest side. But to get the longest side, I have to add together the two small guys to get the big guy.
big guy?
Now you gotta figure out which one you're gonna be an expert on. When it's there, I'm subtracting to be an expert at that, or when it's missing. The question is, well, is the answer 1? And is the answer 7? No, it's not that. But at least I know exactly what I need to do to get it. Here's how I get the rest of the answer. Everybody gets a little 2 and a house. Everybody gets a little 2 and a house. Punch that into the calculator and I'm done. Now I'm going to do the long version for over here so that you can see that it works with the long version. But again, once you get used to the fast version, if it's there, I subtract. If it's missing, I add. All right. By the way, the answer to this one is going to wind up being, let's see, a 16 plus a 9, which is a 25, which is going to equal a 5. 3, 4, 5. It has to be a 5. That's the way it always works out. 5, 4, and a 3. You're going to be a 25 minus a 16. Still inside the house. 25 minus 16 happens to be something like a 9. Square root of 9 happens to be a 3. Let's do the answer on that one. There's an answer on that one. Alright, let's do this big one, and hopefully it is a 12. Do I have space? Where do I have space? We'll write on the rabbit. By the way, there is a difference between a rabbit and a hare. Anybody know the difference between a rabbit and a hare? I'm writing up here, but you can write wherever you have space. Anybody know the difference between a rabbit and a hare?
Isn't it the ears?
It is the ears. One of them has longer ears. I think the hare has longer ears. Here it comes. To actually do this one the official way, you put the hypotenuse of the red guy under C. He's always C. Where are you, 15? And then 9 could be A or B. We'll make it B. Sure. And everybody else, we just put you in, plus sign, if I guess a little 2. You'll see here to get that smaller guy, I'm going to subtract 9 from both sides, so you can see it's going to be the big guy minus the small guy to get the friend. The same thing that I automatically know over here whenever it's the big guy minus the small guy. But let's go ahead and do some subtracting. Let's see, 9 squared minus 9 squared. It gives me an A squared. I'm going to put the 15. I'm going to put the 9. To get rid of the little square root, you always do the house. That's how I know they're going to wind up in a house. Again, on the test, these are the ones that you can skip. These are the harder ones that I'm doing now. And the concept behind them is some people may want the harder ones to get a higher score. The others are like, no, I'm cool with getting my 12 out of 17. What are you? A squared, which is now just A because the radical and the 2 cancel, leaving the stuff inside the house, which I'm not going to finish. Oh, maybe I need to. 225 minus 81. Someone on the calculator do some subtraction there. It's a 12, so it must come out to 144. Never mind. Square root of 144 is just a 12. And that is what A is. In other words, I'm going to pause here so you can catch. If you're writing, let's erase some stuff and actually get the final answer. They want the perimeter. You're on. Right. They actually want the perimeter.
42.
42 will be it. Let's see. For those who... Alright, so here's the deal. To put the perimeter, you add all the outside guys, the green. So you're green. If you're a rectangle, the bottom is the same amount. You're a 12. Of course, the opposite guy is a 12. So to get the perimeter, you just add all those guys, which is going to be 9 plus 9 plus 12 plus 12. Add all the outside guys. You said it's 42? To get the area, let's make you guys in blue. In blue, you only need to multiply 2 of the outside guys. They have to be the guys kind of connected to the L. And so 9 times 12 equals the 108. Now the deal on this one is going to be, it's all or none. So let's say you get the perimeter right, but you get the area wrong. Sorry, I'm not able to give it to you. You haven't mastered it. So it's a lot of work for 1 point, but again.
You forgot your unit.
They have M those, which I guess technically there's supposed to be a big deal, which is saying that the perimeter is linear units. In other words, there's no power on it, while the other guys are going to be to the second power. But for me, If you got the number part, I would still give you credit even if you didn't have the unit. Some other teachers probably mark it off because on the standardized test, they probably put the correct answers in the wrong units to see if you know that. But for my purposes, you get that 108, you get that 40. Can you name a triangle in 3 different ways? To name a triangle in 3 different ways, you simply label the triangles. So I'm going to do ABC because that's standard. Let's do ABC for the big guy. You can choose any letters you want if it was for you. For the small guy, I'm going to do XYZ. XYZ. Take you put a little slash on the Z to differentiate it from the number 2. And here's what the ask going to be. Name the first triangle using 3 different letters for each vertex. A vertex is a corner. I don't use that phrase a lot, but a vertex is a corner of a triangle. Then use a different set of 3 letters for the second triangle's vertices. More than one. You have 1 vertex. You have 2 vertices or more. Make at least 2 different similarity statements. 2. I thought they had 3. We'll make all 3, but you can choose any 2 that you want. It simply goes this way. I'm going to put the letters above each other, and that way you can see the different choices. So let's see. I have triangle ABC. And similarity. Do this, they need to mark that part. Circle similarity. So you know why I'm using a symbol. Blue guys, your triangle X, Y, Z. Here's what they're asking for. Name the triangles in the original way first, then start with the letter B second, then start with the letter C third. Let me show you what I mean. You can choose any 2 of those that you want. So, for B, all what I'm writing now goes for B, but I'm going to put it up there because it's convenient. One of the 2 that you can write is, hey, triangle ABC is similar to triangle XYZ. That's one of the 2. The second one, I'm going to start triangle BCA. I'm just going to start with a B and wrap around. Triangle BCA. Triangle BCA is congruent to, now I'm start with the second guy here, CZX. That's all they want on this. YZX. The third option, which I'll do in all green, but they only wanted 2, is to start with the last one. CAB as in cab. Triangle CAB is congruent to, is similar to, all in green. Start with Z, X, Y. You will notice the letters always match up. Anywhere A is, if it's at the beginning, X has to be at the beginning. If A happened to be in the middle, where are you, A in the middle? A in the middle, then X has to be in the middle, and then lastly, if A was at the end, X would have to be at the end. Take a look at that. So, I'm going to use this space up here for number 18. We didn't do it this way a long time ago. The algebras did it this way, and now I see why they did. I just did the whole 45, 45, same with a radical 2 on here. But what if they don't put a radical 2? Then you're all messed up. Or on this one, I did 30, 60, 90, where we see the 30. Right. But what if they start you off with the 6, where it goes? I gave people points. So, all right, here we go. Let's put in your double 45s. What do you need to know? You need to know that there's an original picture with a 45, 45, and what goes on the original picture. 45, 45. There's an original picture that goes with the 30, 60, 90. Now, for those who go beyond in math, well, they have to. This will show up again, so this is one of the few things where it's like, okay, yeah, for sure you want to know it, so that when they throw it at you again, let's see, put in my 30 down here. All right, so here's what actually goes on the 45, 45. There's a 1, and a radical 2. That's what actually goes on that picture. The 30, 60, 90, technically there's an invisible 1 in front of the radical 2 for the same that I told you before. Here, yes, that radical 3 really does go over there. A 1 and a 2, it really does go there on the original. It just works that way. Technically, if I were to, these are right angles. Let me pause for a second. What if they change up the numbers, though? There's a 13 here, not a radical 2. There's a 6 here, not a radical 3. you match up the sides that go together. Here's what I mean. For the original, I need to find 13. I need to find the bottom one. A y is missing. So here's what I'm going to do. I'm going to put a 13 over a y. 13 over a y. Then go up here to the original and see what two sides I use. The hypotenuse in the bottom. Hypotenuse in the bottom equals there's radical 2 and a 1. I'm going to cross multiply eventually, but let's set up this other one over here. Oh, I'm sorry, for the x. If I need to find x, I'm going to put the 13 over the x on the original. Run out of space. We'll set it up, 13 over the x. On the original over here, let's see, there's a 13x, radical 2 over 1. Radical 2 over 1. We'll do the same thing over here so you can see the setup, and we'll solve one of them. A million of them are set up or solved over here, but I'm just going to solve one of them because they all solve the same way. Over here, let's see. I need the x. I got an x and a 6. Where are you, x and a 6? I got an x over a 6. Over here, let's see, top and bottom. Top and bottom. And I'm going to do the same thing with the y. I have a side and bottom, side and bottom. After I set them up, I'll pause and I'll solve one, and then or maybe we'll solve two. One with the radical 2, one with the radical 3, and that'll be it. What am I doing? I'm doing top and the bottom, I'm doing side and bottom. Side is a y. Side and bottom equals up here, a side and bottom. That's a 3. Should be a y. Looks like a 4, like a p, like a who. Let's make it. Alright, pause. We're going to solve this one right here. I'm going to erase this down below so I can have some space. Dang it. Do I have an undo? I don't have an undo. And let's see, I probably had where am I? Top and bottom, top and bottom. You want a 1 there because when you multiply 1 across, let's do it in blue. Blue and black, blue and black. Sure, why not? Blue, 1 times 13 is just 13, so that's fine. The black, y times the 2 is just a radical 2. Where am I? You're black. So the first move is just cross multiplying. The last move, you're just going to divide whatever's next door to the letter on both sides.
No pressure.
No pressure at all. So I'm not taking the test. All right, so here we go. Let's see. Let's divide that 2. Sure. Radical 2. Radical 2. You're almost done. 13 radical 2. The only problem is this next level. No, you got to do it. The last thing is you can't have a radical in the denominator. How do you get rid of a radical in the denominator? You multiply it on the bottom and the top. For those who know patterns, here's what's going to happen. The number inside the denominator is just going to come out. The bottom of the answer is going to be a 2. And the whole radical thing is going to go to the top. Every single time, that's how it's going to end. With this radical 3 on the bottom, radical 3 will go on the top, and just the 3, the number itself, will stay on the bottom. Now I'll show them how to officially works, but that's how it's going to be. Here it comes. How do you get the radical out at the bottom? You multiply the radical times itself on the bottom and on the top. On the top, you wind up with that same 13 radical 2. There's nothing you can do about it. On the bottom, 2 times 2 is 4. And the square root of 4 is a 2. In other words, dang it.
Erase it.
Has to be written in there. You're the answer. Look at the answer, see if you see it. And let's start working on the other guy, same concept. It's a lot of stuff. Which is why, again, not hard stuff, a lot of stuff. Let's do this guy over here and be done. Last problem ever. Yeah, look at this. This is it. This is that final moment. Yeah, where were you when JFK got shot? Yeah, where were you at 9/11? Where were you when the space shuttle exploded? Where were you when When Biggie got shot,
Big.
where were you? I don't know what happened recently. All right,
I was alive. Small.
all right, here it comes. I'm just going straight all black on this one. Basically, there's some moments in life where you were a certain place because it was a momentous occasion. Here it comes. Yeah, like some people blew up. Were you guys alive or no? No, of course.
Teacher, you mean?
Yeah. Yeah, I don't know what year. Yeah. Yeah, and it had to be too early because I have to remember where I was and I don't remember. Where were you when you saw the second thing hit the tower? You guys were alive for that, yeah? Oh, dang. Okay. All right, never mind. The last piece. Yes, please. Go.
About the Hurricane Patricia. It was bigger, and then there was like no deaths in Mexico, and Katrina was smaller, and there was like so many deaths right here.
Oh, I see what you're saying. You know, for a second I thought you meant Hurricane Katrina, but then you just like whatever. Say whatever name comes to mind. But there was a Hurricane Patricia in Mexico, yeah?
Yeah.
And it was big like Hurricane Katrina.
It was bigger,
But
but
they-
there was no deaths.
Who was the president of Mexico at the time? If that 3 can go, if the number on the bottom can divide to the top, the answer they have on a standardized test would be just 4, radical 3. Because 3 can go into 12, they're not going to leave it as a fraction.
Thomas, what will be being used for?
You won't.
Like in real
Yes.
life? You won't.
Just to get a diploma. Unless you happen to be a surveyor at this time. This X here? This one here? Yeah, I just kept changing them into different colors, but these are all the same X. Yeah. But no, most high school